Okay, so we are live. A very warm greeting to one and all present here. Thank you so much for joining for today's session. I am Piyusha Nair, the head coordinator of AICVS Commons. AICVS is the Artificial Intelligence and Computer Vision Society of Commons Pune. Artificial intelligence, computer vision, deep learning, and machine learning are a little overwhelming to get started as a beginner. And hence, we as a club aim to introduce these sessions through various workshop, events, and competitions. We are very excited to begin this academic year with a speaker session. Our speaker for today's session is Miss Darshana Pondkule. Darshana Darshana is a senior software data science engineer at Whirlpool. She is a graduate in electronics and telecommunication, and she has completed a postgraduate in artificial intelligence from our very own college. We are very excited to have you with us. Without much ado, I would give it to Darshana. Over to you.
Yeah, thanks Piyusha. Thanks Pranjal for helping me out in here. So hello all. It's really overwhelming to sit on the other side with as a speaker. So it's really great to start a session as a speaker. So I think Piyusha, can you see my screen so I can begin with it?
Yes, your screen is visible.
Right. Okay, so hello all. So maybe this might be a really interesting topic to you all, and I'll try to make it interesting with such a great enthusiasm and maybe the registrations that we have got. So just to start with, what is GitHub and deep learning, computer vision? So to start with, we'll start with the first slide itself. So what it tells you, like here is the human brain, it is mimicking those four slides over here. So AI, then we have some gears in our brain, and then we have some automation stuff, and we have neural network, right? So our brain also has neurons, also has connecting links, and also it performs a task with human intelligence. So now we are transferring this human intelligence to the robots, and that where AI comes into picture, where robots take those human intelligence and perform work. Instead of humans, we just set in robots over there. So now today, there might be some people who are new to this topic, new to this world, and I'll try to introduce you to the deep learning and computer vision world with the help of artificial intelligence and GitHub. So here you can, on the right hand side, you can see like there are some stuffs like machine learning, AI, data mining, automation, pattern recognition, neural networks, algorithm, and problem solving. So generally to say, problem solving is the basic blocks to all this. So whenever you want to solve any problem, you should have that problem statement, and you should have those features. So okay, this is the problem statement, these are the features and what we can do. So there are some stuffs like automation, robotic process automation coming into picture, also pattern recognition we can see, neural networks are all in there. So we can like we'll start. Okay, we'll just not get into deep on the first slide itself. We'll start with the first slide. So maybe so the second slide, I'm sorry. So that's the GitHub slide. So starting with what is GitHub? So GitHub is a like a platform where you can collaborate with other like projects who are giving their projects on this platform. You can collaborate over there, and you can share your code, you can update your code in the others repositories, and you can work together for a project. So GitHub is a platform. It is an online platform where you can upload your codes, you can work in as a community, you can push and pull the requests, you can commit changes in that repositories, and also you can add in issues. So in GitHub there are projects like, if I can say, if I have a GitHub account and I have uploaded some certain number of projects in my GitHub account. So what you can do, instead of typing in at your end, you can just download that GitHub repository, and you can check it at your end also. So this is the icon for GitHub, and without a further ado, we'll start with what is actually GitHub. So I'll just move into the repository. Piyusha, just get me a check if my screen is visible for the GitHub platform.
Yes, your screen is visible.
Yeah, sure. Okay. So I have two accounts right now. I have opened the two accounts in here. This is the one account that I have opened in, and I have the second account where my projects are available. So here we have the second account. So what I'll do is I'll show like how GitHub can be used to create a repo and how you can upload the codes. So there are like two main, also there are version controls, that is Git and GitHub desktop. So instead of using the online version, we can use these two versions also to push the codes, right? So in here I'll use the online version to get start with GitHub. I'll just start with the online version itself. So okay, we'll start with it. So this is the account. Maybe we'll go in up here. So this is the GitHub link, and this is my repo. So whenever you log in to the GitHub account, just sign it up and just log in, and you'll see your profile over here. Your profile, your repositories, your code spaces, your projects, your stars, whatever stars you have got from the other coders or other like collaborators, you can see it over here. And these are some options. Okay, so your repositories are available in on the left hand side also. So these are some repositories, and here you can see the names of that repo. So how to create a repository? So basically click on new, and here a window will appear wherein it is specifying create a new repository. So just for a trial, we'll start with a trial one. And yeah, so here you can see the owner name is like popping up, that is my name itself who has created the repository. Then you can add in the details of what actually you are doing in this repo. So if you are building a network, if you are building a CNN, or you are building a model, you can add that description in this, and that's completely optional. So you can just add in for the better understanding about your repo, so what actually it has. So you can just add those details in this description box. Next comes with the public and private account. So this public is anyone on the internet can see your repo, and anyone can download your code, right? But in private, if you make it private, only the person that you choose to, like he will commit in your repo, or you'll choose a group that only those members can download your code or can commit into your code. Others will not be able to see your code and not be able to see your repo as well. Okay. So now going to the next, I think that might be clear for these two options. So we'll hop on to the next one, that is the add README file. Now this README file in here, you can add whatever. Now if you have some extensions that are needed for your project, or some we can say trial libraries, or some that needs to be installed at the backend to run those codes, so that you can specify in the readme file itself. You can click this tick box and just checkbox, and then you can just add in there. Okay. And here the main is choose the license. So if you have the license specified in here, maybe GNU general public license, you can add those licenses as well. MIT license. So for now, I'll go with none option, and I'll create the repo in here. So, okay. So after creating a repo, here this is the page that you can see. And in here, you can see the comment like a command line. Here, what I have told you, that there are two version controls, Git and GitHub desktop. So whenever you want to push your code from GitHub desktop or from Git, you have to use these like certain number of comments. So if you want to add a README file, you have to add this in the Git, and then your readme file will be created. Now in this web version, it is already like we have to just tick in, but at the Git side or Git desktop side, you have to like commit this, like you have to give these comments and just enter, and then you will end up with the repository, right? So right now, as we are starting with a simple program, I have logged in as a website user, and what we will do, we'll upload from the existing like local directory itself. So choose your files, whatever your files you want to upload, you can choose it. For now, I'll take this. It's the simple code, like it's print hi. So I just wanted to introduce you with the GitHub. So I had like a simple code in there. So now my file has been uploaded. You can see it up here, git.py. Now what you'll do, here you can commit the change. Now this is your main file, so you can type in main file, I'm sorry, file, and you can add some description also about that file, and you can commit the changes, right? So after processing your files, here it is. Now you can check in your GitHub repository. This is your GitHub account. You can see your repository has been created. It's the trial version. And in here, you can see your code, right? You can also see your code in here, right? It's the simple code, and here is the contributor name. Contributor name is Darshana P19, so ever has contributed to this code, he can access it. So okay, so this was up till now, and now what we can do now, if I am the other user, like if you guys want to edit something in my code, now what we can do is like check in with the second user. So this is my second user account, so I have created it to just go through how you guys can contribute to others repositories. So consider this as your account right now. So now if you want to hop into my account, so just paste maybe this one. Okay, you have hopped into my account. You can see those repos in here: ML Basics, Tic Tac Toe, Data Visualization, Project 22, and Trial. Right now, I'll open Trial. Okay, so that's in my trial. Now you want to add something in this code. Okay, so what you have to do, so you cannot add in here directly in my main file. As you are the contributor, you need to fork this code. So fork is the option wherein this code, what you'll do, you'll fork this, and now this code owner will be your name. So whatever, whoever is willing to contribute, his name will pop in there, right? So here the contributor name has been changed. So it was Darshana P19, now it is Darsh P19, right? So here you can add your own description for that code and just create a fork, right? Okay, so this brings me to your session, like your at your part. So consider this as your account. Okay, I'll just tell you how at your end you can add some comments in there. So you can check into your repo. You have forked, so fork from Darshana P trial, and you can open it at your side, right? And now you can change it. So you can open it and you can edit here. Maybe now I'll type in print added new feature. Yeah, I'll just close this. So I have added something. Now this is from the other user. He has added some feature in the main file itself. Now this, what I'll do, I'll just commit the change. Commit changes in the sense you are uploading something from your side to the main repository. So you have to specify whatever changes you have committed. So now I can specify here added new feature into the main repository. You can add the extended description also. If you have added a model, then you can specify that model details also. And here you can see there are options. So commitly directly to the main branch. Main branch is the branch in here. So this is your main branch. So you'll commit that changes to your main branch. That is Darsh P19's main branch at your end. Okay. So this is commit changes. Now that your code is ready, and here you will see two contributors, right? because this code has been forked from my directory, my repo. So I'll be the contributor and you'll also be the contributor because you have committed the changes in this repository. Okay, so these are the contributors. Now you can see at other end. Now even if you had made changes, right, it is not reflecting at my account, Darshana P19's account. It is not reflecting yet because you have not pushed that code to my main directory. So to push that code to the uh, collaborators account, what you can do is the second step. You have to pull the requests. Okay, so you have pull request in the sense you are like pulling, you are giving some request to the contributor that okay, I have made some changes in the code, please go through that changes, and these are some important changes, you can add that into your main repository. So you are requesting, so you are pulling the request, right? So you'll open new pull request, and in here, now you can see that contributor had just contributed for this first line, print hi. And whatever you have added, it is in the green, added new feature, right? So you can see whatever changes are there in the code in this file itself. Okay. So, okay. And this, now you want to commit this changes or pull that request into the base repository of the contributor. So here you can see the base repository is popping the name of contributor as the base name, and it is here you can see whatever your name is. So at your side you can see your name and your main. Okay, and able to merge. Branches are automatically merged. Once you are done with this, you'll create a pull request. In that request you can, add a new feature, added a new feature, you can write a comment, and you will just create a pull request in here. So now this branch has no conflict with the base branch, and you can just check in at the other account. So maybe I'll refresh this page of the contributor, and here you can see there is pull request one notification that is popping up. And here you can also see somebody has forked my code, means he had like forked to his own repository and he had made some changes. So these are the forking, and here you can see the stars as well, right? So here we will see in the pull request, so this is the request that has been made. You can also see the code, whatever changes are made in the commits section. I changed maybe. Yeah, sorry, that's in the file change section. So whatever changes are there, you can see it over here. You can add comments also. Here you can just add you in your comments. If you don't like this, you can add it. Okay, I don't want this feature and I'll not pull your request. Okay, I'll not merge that into my main code, that you can add it here. For now, we'll just, okay, I like this feature. Okay, this is good. It's great going for me. So what I'll do is in the conversation section, now in here, you can see this is at the collaborators end. Okay, it is not at your end, it's at the collaborators end. It's my directory for now. So you can see it's my directory, and someone has requested to merge in, right? So now I have seen the code and I'm okay to go with the code. And I'll just, what I'll do is I'll merge the pull request and confirm merge, right? Now you can see that my code has been merged. So in the code section, we'll go to github.py. Till now it was not, showing. Like it was showing just a single line. Now that somebody has added a new feature, now somebody has contributed in, so that's why we can see added new feature also in my main repository. And here you can see your name as well, Darshana P added new feature, right? So this is what pull request and commit changes are. So similarly, what we can do is we can add issues to the main, like main file also, and how it goes same, like the pattern is totally same. We can add issues in over here. um, so if something is wrong, like there is some bug in some line, okay, so bug in first line itself. Maybe that description, if you can write in the comment section, with 2 stars, image needed to be added. Yep, and just close in with this, right? Here you can add assignee. So for now, I have just one assignee. You can add in, if you have group of people, you can like just add those in that, and that person will know, okay, this task has been assigned to me, and I'll work on this. So these are the assignees section, and you have labels. So in labels, you have bug, documentation, duplicate, enhancement. Okay, these labels specify what type of actually what actually comment is it a bug, or is it a documentation, or where it is actually reflecting. So you can add that labels and submit the issue. So similarly, whenever you submit the issues, that issues will pop in into the issues section only. So you'll get one over here, and you can resolve that issue. For now, if I submit this issue, okay, so in this issues section, you see one number has popped up. So that issue is popping up here, bug in the first line. So here you can open the issue and you can see, and if at your end, if you are done with the issue, you can leave a comment, yeah, done with the issue, and close the issue, right? After closing the issue, you can see open and first issue has been closed, right? So here these are some basics of how to use GitHub. So there are like many, you can search in for many collaborators are there who are investing their time on GitHub, and they are providing their codes. Like for CNN, they have some innovative codes you can collaborate in. If you have some innovative ideas, you can just collaborate in, and you can add your features also to the collaborators ideas, and you can work on a single project at this platform itself, right? And you can also, if you have certain number of codes, if you found some repository that is really interesting, and if you want to work on that repository at your end, at your local end, so what you can do is you can download that repository or clone that repository. So for cloning, even we'll go to the cloning part itself. So Colab is a really good platform to directly clone the repository. So for now, I have taken this. So for the newbies, maybe Colab is a platform where you can code directly. It's similar to the Google Sheets. So whenever you add some people to your sheets, they can also share your code, like share your sheet, and they can also simultaneously add into your sheet. Similarly, Colab is also a coding platform. It's a notebook wherein you can code in, and maybe if you share this notebook, other people can also contribute into your notebook, and they can do the work simultaneously with you. So here you can start coding, right? So this is the repository, and here you can mount your drive. So whatever contents are your in your drive, that will be seen in this collab section only. So in Git, now that I am in collab part. So what I'll do is I'll show how to clone the repository in here. So you can do, what you can do is, if you found some repository, like I'll take this tic-tac-toe algorithm. Oh, okay. So what you can do is you can directly download the zip file, or also you can, as I have told, you can open it into the GitHub desktop. So this is also a second platform. This is a version control platform at your end, and it is much faster than this website. So you can just push and pull requests that at really faster rate. So that's really handy. A GitHub desktop is really handy. So you can open this code at your end also without downloading. Uh, and if you want to clone this repository, you have to just copy. You have this option, just copy this and just put it in here. This is the command that you need to give, and just put in here and just copy, right? Okay, and just run this cell. So you can see cloning the tic-tac-toe, and after cloning it, you'll see that in some time it will be reflected in here. So basically, we are unpacking those objects. Sorry for the delay. I think it's okay. Just clone and okay. So you can see I've cloned that repo and you can see that file as IPYNB in here. You can directly open that into the Colab section. As this is a notebook, so it has been opened as the second part. So you can see all the whole code in here. You can just check in at your site and you can just edit in here. This is the raw source code. So yeah, this was about the Colab platform. So maybe we'll move to the next session, like section. Piyusha, are there any questions on this up till now? Maybe we can take
Uh,
those.
Darshana, we do have a question. A
Yeah.
student says that she has heard about clone before, but she isn't really sure about how it works till now. So you
Okay.
might want to throw a bit of light on that again.
Okay. I'll just repeat that for you. Um, So clone is actually what you do. Cloning a repository means you're pasting certain okay, this is my repository and these are the files, right? Now you will not start downloading each file at your end. So what you can do is you can clone this whole repository. Whatever files are present in this repository, you can get it at your end. So what you will do, you will just copy, as I've told, just copy and just take it into the collab section. Maybe you can download it also, but for cloning I've used collab. So just paste in here. Now that, okay. So here you can see whenever you run this code, you will see the readme file is available and the tic-tac-toe IPYNB file is also available. Now clone in here, what is actually, if some collaborator has uploaded the data set also, so you'll not sit and do one by one downloading, right? You can download that whole repository at once and you'll get all those files at your end. So that is basically what we say cloning, right? So instead of downloading one by one, you will just clone that whole repository. So whatever files are in there, you'll get at your site, right? Hope I have answered your question.
Sure, Darshana, that was pretty descriptive. I think whoever had the question might have a clear idea now.
Yeah.
I think we should continue.
Okay. All right, then we'll go to our next section maybe. Okay. So this was about the GitHub platform. Now we'll move into AI, ML, and DL, a huge, huge world, right? Like pretty, I have worked for maybe 9 months internship I've done in the AI, ML part, and I'm working for maybe at a Whirlpool in this domain only. So it's really a huge world, right? And whenever I talk on this, so it's never too late to learn AI, it's never too late to learn ML, and it's never too late to learn DL. Okay, so AI is everywhere. So you are sitting with AI right now. You are like having your phones. There is in there, you have face recognition, you have speech recognition, right? Whenever you can take example of Tesla also, so that is also an AI. So you have AI everywhere, you are around AI. There are like models are watching you, they are training itself and they are checking your habits, right? Okay, this user logs in at this time to Netflix, maybe that checking in your details, like checking in your history, and they are training themselves. So instead of human intelligence, they are taking that tasks, like taking up those tasks to themselves. So AI is a huge bubble. So in there, we have machine learning, we have data science, we have deep learning, computer vision. It's really a huge world. Now, what is actually AI? So AI is where we, enable computers to perform the human task. So which normally require human intelligence. So whenever I'll take an example that is about the medical robot. So in here we have deployed a medical robot which performs a general surgery. Okay, so general surgery like stitches. Like if stitches are there, he'll perform that operation and he'll do that. So that is a general surgery, and that now that surgery has been replaced by robots. So robots are performing those surgeries, and they are performing really well with really precise and great accuracy. Now they have replaced those doctors. Like some tasks are really, like, it consumes less time, so those tasks are done by the robots itself. So that is actually artificial intelligence, where you train the machines to, mimic the human behavior. So that is actually human artificial intelligence. And now, what is machine learning? So machine learning is actually a part of artificial intelligence, in where, you build models. So if I take an example of a classification model, maybe. So if I want to classify some, okay, this transaction fraud or not, is this a transaction valid or not. So here we build a network, we build a model, we add in the features and we train that model. Okay, if these features are present, like, it is valid. If it's not, if these features are not present, it's not valid. So we are implementing certain number of techniques, right? And we are deploying that model at the background. So like, you'll not see that model, but it's performing its things at the background itself, right? So in many companies, we have, in banking applications, we can say they have fraud detection. So they are applying machine learning models in there. And also, if I want to, generalize it, we have also the recommendation systems. So even if we check Netflix, so it is applying the machine learning model at its end, and it is providing you the recommendations. And now you don't know what model is actually applied. It is running in the back end, and it's training itself, right? What are your habits and what are your likings. So it's training at the back end. So that's how machine learning is in the bubble of AI, right? And next is the deep learning. So deep learning is now subset of machine learning, in which we use ANN, that is artificial neural networks, and CNNs, that is convolutional neural networks. So ANN is basically a short network. If we have input layer, we have hidden layer, and we have an output layer. But when we want to build a huge network, and you want to build a network that can, extract the features, that can, have a large data set. So here convolutional neural networks comes into picture, in where hidden layers are more, right? So okay, so maybe this could be a great start. So I'll just go into the next topic, like AI use cases. Now that machine learning and deep learning are the parts of AI, so we'll check into the use cases now. As I've told, there are speech recognition, facial recognition. You have your android mobiles, right? You have facial recognition, that is an AI. Speech recognition, Siri, Alexa, that is an AI. You have fraud detection, recommendations, as I've told, Netflix, right? Amazon, even on the website. So if you have checked, now you have checked something on Mintra and you want to order it, right? Whenever you visit certain other website, or even if you can see on the Instagram, you get those notification. Okay, you have checked in with this, these are the recommendations for you, you might like this. We get such recommendations at our end, right? So it is helping us to shop faster. So here also AI plays an important role. Okay, we have chatbots. So now many websites are hosting chatbots for their customer service. Even as a product company, as I'm working in the product company, we also have a chatbot for the customers to, serve them for 24 hours. A human cannot sit in at one place and can serve the customer for 24 hours. He has to, like, he's that is really a tiresome job to some do those things. A customer has requested for the ID, he has some issues, he has some questions. I am really I cannot work for 24 hours and I cannot provide those details. So here chatbot comes into picture, which are already pre-trained, and they like provide in or they help you with the flow that maybe your request, and they are trained for that. So you'll see at the right hand side there are the chatbots popping in. Hi, maybe I'm Alexa and I would like to help you, what are your questions? So they are popping in there, right? So you can interact with those chatbots also. So we also have spam detection, we have machine vision, cancer detection is also performed. You might have seen those algorithms that uh, cluster out or just classify the cancerous cell. Is it malignant or is it benign? So this is also been implemented in the maybe medicine sector also, and autonomous vehicles. So we have the great example of Tesla to detect pedestrians. Okay, so in here I would like to add in something. It's not just detecting pedestrians. It's really whenever you see a autonomous vehicle, there is a lot of work, guys, that works in the background. You have image segmentation. It's really huge. It's you have to annotate, okay, this is a man, and you have to classify this as pedestrian. You have to, like, we have from our childhood, we are training our brains to classify the objects. Similarly, we have to train the model with huge number of data set to classify those objects. Now model cannot get up and say, okay, this is pedestrian. It will not perform like us. We have that human intelligence, but we have to transfer that to our model, right? So that we need to build a data set. We need to work in with the data set. We need to do pre-processing. That there are lot number of steps. It is a huge project. A single person is working on just image annotation part also. So there are like many hours invested into single maybe task. So it is a really huge process before deploying any project. It's really a complex process in there. So okay, so these are some AI use cases, and companies are investing really a huge amount of money in those. So speech recognition, facial recognition, recommendations. Banking sector is investing in fraud detections. So companies are really investing in here. And I have attended a seminar on AI. So they are like, there are a lot of job opportunities in AI. Just the talent needs to fill that gap of that AI engineer, or maybe that gap of the whatever skills are needed. So as and when we do projects, so certain number of projects, we'll get to know the skills, we'll train those models, we'll see what are the pitfalls in there, and we'll add in our features also. So our brain also starts working very fast when we train those models also. So it's really about patience and determination. So you just have to go in and you have to dive in that sea. So there are really lot of platforms that are helping us out. So yeah, there maybe we'll go to the next slide. So deep learning, yeah. So deep learning, as I've said, is part of machine learning. It's the artificial neural network, and I'll just cut it into short with this GIF. So you, as you can see, you have an input layer, you have a hidden layer, and you have an output layer in here. So whenever you pass certain, now consider this as an image. You have certain number of image. Now you have passing it to the network, right? So it's dog. We can clearly classify its dog, right? Now my network has to be trained in such a way that it needs to classify it as a dog. So you have to, now these, what these are called, these are neurons, right? And in here, the connecting links, you have weights. So adjusting the weights, we are extracting the features and we are adjusting the weights and we are training that network. We have weights. There are lot many parameters in here. We have weights, we have biases, we have hyperparameter tuning, we have activation function. So when you dive deep into it, you'll get to know all this, right? So these are the main. Hyperparameter tuning is the main, where you tune in with the activation functions. You drop out the layers, you check, oh, okay, which function I need to apply. Okay, so this is the main, right? And after that, maybe, okay, so that is what actually ANN is. input layer, hidden layer, output layer. Whenever hidden layer is more than one, it is classified as CNN. So that is CNN. Okay. So yeah, so maybe we'll start with brainstorming. So I have told you with what companies are working on, what corporate world is working on. So basically, you know, the main thing is to collect the data. So maybe as a computer engineer you have a databases, right? Now data you'll not get into a single format. Now if you say, okay, I have got data that is in the CSV format, you cannot sit back and say, okay, CSV format is okay for me, I'll work on that format only. No, there is data that will be available in the demographic format also, maybe in the maps, maybe in the Excel sheets, maybe that will be in the database like SAP and all. So you have to collect data. Pre-processing is the main step. So unless and until you get the data, unless and until you check on whatever data is there at your side, you'll not be able to build a model, you'll not be able to think of the statement. So big data is the main part. So data collection is the main process of the business, right? So here you have to collect the data. That might be from any, maybe it be images, or may you have to think about it. Okay, this is, these are the main features for my model. So you have to check which features are main for my model. And yeah, one thing, so what is the big difference from machine learning and deep learning? I forgot to tell you that here in machine learning what we can do is, machine learning, we collect a data set, and what we do is we fit that data set to the model, but we give features. Like if my columns are present A, B, C, D, so those are the features. I tell the model these are the features and you can work on these features, right? And then it will start its testing. But in deep learning you just provide a data set. Now the model will automatically extract its feature and it will train itself. So feature extraction is done by the model itself. That is not in the case of machine learning. You have to provide the features from your end, right? Okay, so that I just left. I was left to point it out. So that was the main part. So okay, so coming in here, the data collection part, and after that, you whenever you have collected the data, you can try it with your training examples. You can just play with the data. You can just model it and check it if you are getting the desired results, right? So if you are getting those results, or if you need certain amount of data more. Okay, now my model is underfitted. Underfit and overfit are those terms in where your model, if it learns less, if it has less feature, then it gets underfitted, and maybe it will perform great in the training part, but it will not test. It will not have great accuracy at the testing part, right? But in if you check it, the overfitting model, overfitting is where in your noise also gets overfitted. So training, you'll have a great accuracy. Testing, maybe if it's not a dog but certain features it's showing about dog, so it will classify it as dog. That is a false positive, right? So that is a overfitting of the model. So you can check it at your side by training such examples. You can check it what features I need and what features I don't. Okay, so you can simulate those examples if possible. And now if you are confident with your model, and if your model has reached that step, okay, my model has accuracy of 90% or 92%, and okay, it's great to deploy this model and it will perform good. You can deploy this model, okay, and you can monitor the process. So there are platforms like AWS, Azure. You can monitor the process as well, and you can check in with that as well. IBM has also its own automate AI platform, in where you can directly, instead of coding a model, you can directly give that data set to the automate AI platform, and you'll have the list. Okay, you can use a classification model in here, you can use a regression model in here, and these are the accuracies and biases it gives in that details at the side only. You don't need to even code. You can also check in the code is there available at the backend. You can download that code also, so you can check in those. So okay, so what I can say in here, these are the four pillars, that is mission, vision, strategy, and tactics. Mission in here is you have to check in whatever the customer demands is, right? What the customer or consumer wants. So if vision is you have to put yourself into that shoes. So okay, and here you can add in new features in there. That is the vision. And the strategy is what I have told. You have to build a data set, like you have to collect those data set, you have to strategize your things, saying okay, I'll take this data set, my this firstly you find that data set that might not be useful, but there are certain connecting links in the data set. If you think okay, this is I'll not need this data set, just put that data set into side, but just don't delete it. But because there are certain connecting links between the data set, so you have to strategize it. And that also comes into the tactics, that how you combine strategy and tactics and how you build a model, right? So these are the main pillars in here. Okay. So maybe Pranjal, if we have questions, we can take it up.
Yes, we do have more questions.
Yeah.
So I'll go
So
from the
I'll go
start.
from the start.
If machine learning is a subset of AI, what other domains does AI consist of?
Okay. Okay, so that's really a good question. So basically, I've told like machine artificial intelligence is a huge bubble. So in artificial intelligence, you can have NLP, that is the next sector. You can have optimization techniques, you can have deep learning, image processing is also in the artificial intelligence bubble. So image processing is there, computer vision is there, machine learning is there, deep learning is there, your NLP is there, your OT techniques are there, image processing is there. There are many, like data science also comes into, not in the whole bubble of artificial intelligence, but slightly it cut off the path, right? So these are such some domains that are already present in the AI domain, right? Hope I've answered that question.
Yes.
Okay.
Also, can you elaborate a bit more on CNN and its working?
Okay. Okay, we can do that. Okay. So CNN is actually a convolution neural network. So basically, it performs as a human brain. Okay. So it has a neuron. So these are the neurons, right? And you have the hidden layers. Now, in here, when you give, take an example, if you give an image to this model, right? So you have input layer, you have hidden layers, and you have output layer. So now, if you give this image to the CNN, what these neurons will do, it will extract the features of dog. So whatever features are there, ears, then the nose, the eyes, okay? So whenever you provide a data set, it will extract those features, the features that are like prominent features, okay? So it would extract those features and train itself. Okay, if it as maybe uh, such a image you have given it, so it's classifying it as dog, so it will extract those features and it will pass those weights. So here you can see connecting links. So exactly here you can see the weights. So you are passing those features according to the weights. So if that feature is prominent enough, that is categorizing it as dog, you will have you'll have more number of weights. That connecting link will have the weight that is in the maybe amount more than the other connecting links, right? So in this you have, if your data set is too huge and if you have images, then you have to implement those hidden layers. One hidden layer is not, you know, like you cannot check in with one hidden layer. You have to implement certain number of hidden layers. You have to implement maybe with two or four, or you have to check in, you have to just check the accuracy, like how many hidden layers do I want. The more hidden layers, the more extraction of the features, right? So you have to check in how many hidden layers you want and how your problems are. So basically now the output layer, you can see in over here you have the output layer with the two categories. As we have two categories in here, dog and cat, we have the output layer with the two categories. So it will classify it as a dog or it will classify it as a Yeah. So there are to elaborate more, there are certain number of features, hidden layers. Then there are activation functions that are applied to these connecting these neurons that are trained according to those, like tanh, sigmoid. Those are the activation functions that you need to go into deep of those activation functions. Those activation functions perform different tasks. There are certain number of activation functions, they perform different tasks, so that would be a huge topic to cover it in. But yeah, to cut it short, it performs those, like, it works as a human brains. It is a convolution, it performs the mathematics. Neural networks learns with the mathematics and statistics. Okay, so whenever my output is wrong, that is fed back to the input. Okay, so maybe I can give you the example of bidirectional LSTM. Whenever it checks in with the output provided, it feedbacks again to the input, and it stabilizes itself for the highest accuracy, right? So it's a feedback network. So whatever you output you have got, if it's wrong, it trains itself and it checks the weights and it trains itself again and it gives the correct output. So that's how the CNN actually works. It's a feedback algorithm. It's just really from a feed forward network, and then it again loop back if it's giving a wrong output, right? So that's the convolution neural network. That, and you can just dive in deep in here. So there are many lot of things, like I have told, lots of things in convolution neural network. There are really many types of neural networks. There are ResNets, there are BGG19, there is AlexNet, Google Nets. These are all pre-trained networks, right? So you can dive deep into this networks. Each networks has some specifications, and they perform really lot different from the other networks. So you can check it at your side as well. So maybe, Kanjal, next question.
Yeah, also, what is the key difference between CNN and ANN? Since we were discussing about CNN, so on the same lines, we have another question like this.
Key difference of what I can say, like I have given that in the first slide itself. ANN is basically in here. The key difference is you will have just a single layer, right? If I have maybe I don't have 50 classes. Maybe I have just one class to classify. Okay, so what you'll do, I don't need uh, many number of hidden layers. I can do that with single hidden layer as well. So that is ANN, a simple neural network in which you have input layer, a single hidden layer, and output layer. But in CNN, if you have many classes, right? If you have to train your data set, if I have dog, if I have cat, I have pedestrians, I have cars, I have many things in there. If I have 80 classes, so you will not work with ANN, because ANN will not give that accuracy. It will just underfit the model. You have to use CNN, which will have more number of hidden layers, which can extract the feature of each class and which can classify each class differently. So ANN is a simple network, and CNN is a huge network where we build hidden layers in there. You can input your own custom hidden layers also, right?
Right. So basically, ANN is just simplified CNN.
Yes, so it's basically the first version of CN, and the first, we can see a start of deep learning. Maybe we can say it as like that. Just input layer, hidden layer, and output layer. Okay, that's all. Yeah.
Right. Right. We have another question. We wanted you to elaborate a little bit more on supervised, unsupervised, and perception learning.
Okay. So maybe I can do that, but that would be come on in the machine learning part. So will that be okay? So maybe I can, supervised learning is actually wherein, okay, I'll just clarify that doubt. How that it works. So supervised learning is actually where you provide labels. So now check in with your Excel sheet. You have an Excel sheet. You have columns A, B, C, D, right? And you have a D column where you are predicting, okay, these number of rows. So ABC is giving me certain number of values, and from that values you are predicting the output. Okay, this is yes. Take it as fraud detection. This is yes, right? Certain number of values, and okay, so if the bank balance, maybe if bank transfer has been done above 1 crore, so maybe that we can classify it as or give it as fraudulent, right? So we can give that label as yes, and if that is not, we can give label as no, right? So what label supervised learning is, we provide the model with such a data set wherein we have labels like yes and no. So we give model with, now I'll just give example. Model has its question paper and its answer paper also, right? It has its question, it has its answer. So that is what is called supervised learning, right? So model is provided with the question paper and that answer. So model trains itself, okay, these are the values. When I see certain values, I'll have to classify it as yes. These are certain values. When I see such values, I have to classify it as no, right? So this is actually supervised learning. It has uh, a teacher, like it's a teacher, right? And in unsupervised learning, basically you just have a question paper, you don't have an answer sheet with you. Model has to just do it do that, it's on its own. So that is actually where in clustering, then maybe what we can say, in clustering part we can say k means comes into picture, then we have gmm in there, and mean shift algorithm. So those clustering algorithms that comes into the unsupervised learning part, right? So we have just a data is given to it, and the model like just hacks into that data and just provides the cluster, and it's not provided with the labels, not provided with the dependent feature. So that's actually what it is, and that comes into the machine learning part. So that is actually where the machine learning comes into the picture. So that is not in the deep learning part. Maybe deep learning mostly handle images, okay? Machine learning mostly handles the data sets like csv file, excel files, wherever the values are, right? They handle such things in the machine learning part. So deep learning mostly it handles the images, in where we can handle those images, we can provide large number of images to the network, okay?
On
So
this
maybe
note, I had an example. I just remember an example rather. So, supervised learning is more like having an open book test for our model, whereas
right.
unsupervised is like giving a viva. You can't really take help from anybody that time.
Yeah, surprise test, we can say. You just have a question paper at your side, you have to just fill in whatever you know, so that we can say it like that.
Yeah, exactly. Also, we had another application-based question rather based on Whirlpool itself. So, do you want to take it now or at the end of the session?
Maybe we'll take at the end of the session. Maybe we'll check in with the next slides before joining in. We can get more questions on that slides as well. So we'll take that question at the end.
Definitely.
All right.
Okay.
So we'll go to the next slide, that is how transformers are changing the game. So in here I've taken a real world example. So transformers are really changing the game, in where it's changing the computer vision part, and also it's changing the NLP part in most of the time. So you know LSTMs and you know CNN. So uh, here NLP comes into picture, where you do natural language processing and you work on the text analytics part. So if I take example, I'll just cut and short. If I take an example, here it is transformers are cool because they are efficient, right? Now if take a close look at this example, they is referring to the transformer, right? Now there are some problems in LSTM and CNN that are maybe vanishing gradient problems. There are problems with the biases, and they cannot, they cannot link some words with the previous words. So if you don't link those words, now if my day is not linked with the transformer, there is no meaning with the sentence, right? There is no meaning with the text analytics. That they should refer to the transformers, and that can be done with the highest accuracy with the transformers. That is also a network in which transformers, it what it actually does, it gives maybe the weights for each word. So each word has weights, certain number of weights. So now in here you can see those blue lines. So the weight that is provided to transformers and day is more than the other lines. You can see the other lines in here, they are faintly in blue, and the most darkest line is with the this part day. and the transformers, right? It is closely relating this. So here the weights come into picture. Weights are actually, you are emphasizing more on that, and you are letting your model know, okay, if you see the day word, it is referring to the transformers, according to the text, whatever we have got, it is referring to the transformers. So basically weights perform that key, and that network, that link whenever I see the link, so these are the links when you connect to the neurons. So in here the weights are present, so whenever your weight value is high, that link gets stronger, right? So that feature is strongly passed to the next neuron. Okay, so that what transformers are, and you can check into the information of the transformers. Transformer in a single part is really a huge topic, and it's booming the world right now. So you can check in, you can check for the already uploaded projects on GitHub also with the transformers. You can take a look on that, and you can check how it is transforming. It is having the higher modeling capacity, and it is having the lower inductive biases. So you can check in with that, and yeah. So maybe we can move into the next slide, that is computer vision. We okay. Okay, so we'll move some maybe faster. So what is computer vision actually? It is also a field of AI itself. So in computer vision, computers have the ability to understand the world through the sight and make decisions based on that understanding. Now, to cut it short, I can give the second sentence, that is, if AI enables computers to think, computer enables them to see, observe, and understand. So maybe computer vision plays with videos and with the images. So surveillance cameras, right? So that is the main example. So surveillance cameras can detect if a person had wore the mask or not. So that is the example of computer vision itself. It is detecting. Maybe I can go to the next slide. So this GIF you can see here, computer vision comes into part. You can see where you can see how the person, how the traffic lights are annotated, and how in the box you can see the percentage also, right? So how, at how much percent it is confident that yes it is car, yes it is person, right? So here computer vision comes into picture in videos and images. You can also use deep learning plus computer vision. I can like at the last, I'll share my experience of how we used deep learning and computer vision in our project itself. So here you can see how it actually works. So maybe I'll give a quick statistic about how computer vision is evolving. So these are some key players of the companies that are investing in the computer vision part, and how they have predicted, how from 2020 it will evolve to 2027. And at the right hand side you can see how the companies are investing in the hardware and software domain. 2015 graph you can see, and 2022 you can see. There is a large difference how the companies are investing. So each company, if you see security, medical, automotive, sports and entertainment, consumer, robotics, retail, agriculture, everybody has started investing in AI, and everybody has started investing in computer vision, right? So this I can say that, as I've already said, that some AI experts are telling, okay, we have a lot of opportunities, that just you need to you need to fill in the gap of those expertise. Yeah, you have to work more, you have to come up with the more models, you have to fill that gap with your skills, right? So this is the part, what I can say, it is at the statistic. Yeah, so maybe this is pretty clear, so how it is working and who are the key players right now. Apple, Alphabet, then Microsoft, Intel, Xilinx. Key players are really more, and even the startups are investing really more in AI. So yeah, Now, these are some types of computer vision: image segmentation, object detection, facial recognition, age detection, feature matching, image classification, and pattern detection. So, these, if you see, these are separate topics, right? Object detection is separate, image segmentation is separate, facial recognition is separate. So, each topic holds its position in computer vision. Image segmentation, in where the segmentation is done. I have a video of that. I'll just play that video for quick minutes, for a few minutes, and I'll show you how it actually image segmentations take are working in over there. Object detection, from these names it is pretty clear what it do, right? So anything, if you maybe you can pop in questions, maybe we can address it later, but from these sentences or these words it is pretty clear what actually computer vision does. What, okay, object detection, it detects the object, like it here, in here it is classifying it as book and not as computer. So it detects those objects. If I want to detect book, it can detect that book in the real world also. So that is pretty clear, right? So maybe we'll move to the next example, that is neural radiance field. Now this is also booming the industry. This has like neural radiance field was like implemented from previous years, but now it has come into picture because of its evolution. Maybe I'll play this video for you guys, and maybe you can check how it is actually working. So just let me know, Pranjal, if it audio is, you can hear the audio.
Yes, it's audible.
It's audible, right? Okay. So what I'll give now, it's what does it, if neural radiance field is a neural network, it's a CNN. What is it does? What it does, I'm really sorry. So what it does, it actually have input 2D images, like 2D images from the 360-degree angle of that particular object, and it will convert that 2D images into 3D image, right? So that is what actually NERF is. It will convert 2D image to the 3D image. Okay. So we'll see how this is. Okay, so that was pretty good to inform. So here to cut this short.
Okay, let's get started
Really
with
sorry.
the installation of the.
Oh, sorry. Okay, so that was the part, and in here what you'll get is such models. Okay, you have those 2D images, and you'll get such models in the 3D part. You'll have normals. You can do your research work also on these models itself. You can use BRDF, you can use Albedo, you can use rendering. So these you can do at your end also. So these models are already, you can check it with the neural radiance field. These models have been implemented, and it's you see how the gap is evolving. From 2D it has converted to 3D. Here also virtual reality comes into picture, right? Virtual reality, then augmented reality. Now corporate world is really evolving with such techniques, and in here they are mixing computer vision plus deep learning, so they are enhancing that. So we can think of such examples in here. Going to the second example, that was of the Waymo cars. So Waymo cars, basically, as I've told how the image segmentation works, I'll just have a clip of the how Waymo cars also work. So we'll just get into that.
Days at Google, we started fully self-driving cars are on the road. They use a range of technology we've built from the ground up to understand the world around them and get you where you need to go. You're about to see how it all works and what it feels like to ride in our car. As it drives, Waymo uses LiDAR, which sends out millions of laser beams per second to build up a detailed picture of the world all 360 degrees around it. It also uses radar to detect how far away objects are and their speed. And high-resolution cameras detect visual information, like whether a traffic signal is red or green. It then combines all that data to understand the world around it. For example, in this fraction of a second, it knows exactly where it is on the road. It can also identify everything around it in full 360 degrees, and then predict what those things might do next. And it doesn't just do that for the objects you and I can see. It can do that for things up to 3 football fields away. What makes everything you can see right now possible is experience. Waymo has already self-driven millions of miles on complicated city streets, and it's constantly learning from every single mile it drives. With all that knowledge, it can plan a safe path ahead. In this instance, giving that cyclist enough room to cycle past us, and also looking out for that pedestrian on the sidewalk. And when it comes to making decisions, this is a good example of how Waymo doesn't just take into account your safety. It also makes sure that both you and the people around you feel secure and at ease. So now that you know how Waymo works, it's time to take your first ride in.
Maybe that would be great. Okay, so that was about the Waymo cars, and in here, what I can say that Waymo cars had like a lot of image segmentation was also done, object detection was also done, age detection was done. Age detection in the sense you can the footpaths, you have seen the footpaths, you can just detect those ages and you can classify it as footpaths. So those ages were detected. So in here, age detections will also come into picture. Image segmentations also come into the picture, where you segment images as person, as a car, according like that, and image classification also. Feature matching maybe not in this case, but yeah. So this is what actually how it is implemented in the corporate world. I just wanted to give a small go through like how it is also implemented in the automobile itself, like automotive sector also. So just I wanted to add in there. And yeah, this brings me to the last two slides. That is what I like we had implemented in our 9 months internship. That was the object detection workflow. So as I have told that uh, when you see a model, there is lot of pre-processing done at the first phase itself. So you have a data set, you do image annotation, you train it, then the model, then the evaluation. So this is the process, right? So there is lot of work done in over here, data set and image annotation. Without data set you cannot move forward because accuracy depends on the data set itself. So what we had done is now we had like image annotation is a part where you have to annotate the images, person, this is car, this is whatever it is, and how many classes you have. Okay, you in a single video you have 80 classes, right? So you have to sit, you have to annotate those. So that's really tiresome, right? So what we had done, we had come up with an application where you'll just have to input the video, and the application will give those annotations, it will save those annotations, it will save those images at the in a folder, and you have to just sit in back, right? Okay, we have developed that application with two approaches. That was YOLO, this is the deep learning approach, and the second approach was the computer vision approach, that was a CSRT, channel and spatial reliability tracker. So these were the two selected approaches in where you can we have built an application which you we have like invested almost 50% of the time of the whole project is invested in the annotation part. So we have reduced that to the 10% part. So that is really, application will perform that for you. Now you don't have to sit it, and you don't have to annotate, right? So application will do that on its own. It has that memory. Okay, this is car, uh, this is pedestrian, this is the signal. It has that memory and it will annotate itself, right? And in here, if you want to add in some classes that are new, maybe now if you want to annotate the images that are present in space, and now space, there are some objects that are not already trained on our models. So what you can do, you can use computer vision models, and you can do it on yourself at your pace in that also. So we have like come up with such an application which have combination of deep learning and computer vision. So corporate now, if I talk about corporate world, they are not sticking up just with certain number, like okay, I'll work on machine learning. No, they're also combining it, like deep learning, computer vision, machine learning, computer vision. So they are working, they are like coming up with new ideas, what we can implement newly, and how we can solve the problems of consumers. So yeah, so that was it from my side. And maybe we can pick up the questions, Pranjal, if we have them.
Yes, the session was amazing. It was pretty self explanatory on its own. But we do have a few questions about the application of deep learning in computer vision. Like, since you worked in Whirlpool, what are the problems you might have solved using deep learning and computer vision there on an industrial level?
Okay, for this question, what I can say is, if I can say, I can give an example of a manufacturing company. So if you see, products are manufactured at the industrial site, right? So there are the workers working. So in there, computer vision comes into the picture. As I told, surveillance cameras. So in here, if my product is on a rail, okay, and if I want to check about its features, and if it is like, okay, if does it have some defects and all, so I can check that from the computer vision part. I can build a model, I can check from that part, and the manual intervention that was needed, like he has to go, the person had to go and check in for the products, like okay, this is good or this is not. So that we have eliminated. And certain, like if the I can say about the wiring. So in manufacturing plant, there are certain number of wiring. So in there we can check in, okay, um, are these wirings at certain positions or not. So that can also be handled by the computer vision and the deep learning part. So there are like really more to say. If we can take an example of a washing machine, so in there deep learning also comes into picture, where we can we have washing machines which they are already in the market, which classifies the stain, right? They're already in the market. They use those models, they use those deep learning models that classify, okay, this is mud, and according to that the water usage is done. We have such uh, washing machines at a marketplace. So these are small examples that I can give in here. Maybe that, I hope that had answered the question.
Yes, it was really nice. Like the applications, it has a great application in the mechanical industry by what we understand as well.
Mechanical as well as software, not only mechanical, because now see, mechanical is what the sector it is embedded with the software also. So it's not just the mechanical part. If we see the self-driving cars, it's not just the mechanical part, a software part sits into that. Unless and until you have a software in that, you'll not be able to drive a car, right? So you have those models in the software part itself. So it's a combination of software plus hardware. If you see a robot from outside, you'll see the mechanical parts of the robot. But in a robot, there are some pre-trained programs that are working. So in here you can see it is combination of hardware and software also. And when you say the deployment of software, so there are some machine learning models, maybe say that time series model, okay. So these you can take the example of forecasting. So these models are already deployed on maybe on AWS and Azure. So these models are already working. They are not using any hardware, but these are already deployed. So you can just input your data and you'll get those answers, right? So it's a combination, I can see. Yeah.
Okay, so what were the several frameworks or deep learning models rather you used to solve all these problems at Whirlpool and at your internship?
Okay, so at my internship, as I've told, I had worked with OpenCV mostly, OpenCV and computer vision models. So there are many models in there. Computer vision, you have a tracker, you have a boosting model, you have an MIL model. So there are many models in the computer vision part. And if I want to elaborate on deep learning, there are YOLO. There are a pre-trained models, that is VGG, GoogleNet, AlexNet. Then we have uh, ResNet as well. So these are the pre-trained models. Okay, you don't have to build your model from scratch. These are already pre-trained on the ImageNet data set that is already pre-trained on thousand number of classes, right? So you have to just import that model and you can add your custom data set as well. So weights are already trained. You don't have to train from the scratch. That are already trained. You can just add in your custom data set and you can get your result from those models also. So these are some simple models and you can work in with such models. So to input here, you have Kaggle, you have Data Government, you have RoboFlow. These are such a good websites which have data sets. Kaggle also hosts competitions, they have really a good amount of statements, and you can just take the data set and just playing with that data set. You can invest your time into the competitions and you can get to know what problem statements are there in the world. Okay, so you can just invest your time in that. So that was a like a pet solution for if you want to start your journey. That is where you can start on. Kaggle has lot number of codes and data sets available on. RoboFlow has also a large number of data set, real life data set available. So you can check in over there also. Yeah.
All right. So, based on your experience in the industry and with deep learning, computer vision, what are some of the limitations you faced during this time?
Yeah. So if I like now I have joined Whirlpool, that is 4 months back. So we are currently working on the projects. But what I can see about the internship projects is that the data set. So limitations is the data set. Unless and until we get the right data set and unless and until we train our model, see, whenever you are working with a model, there is we require a lot of patience to what hyperparameters we need to tune, right? So a model requires lot number of data and it requires such data to be trained on. And sometimes there are situations, if you check in, now my model is trained on the data set. Okay, it knows that this is a box, but maybe sometimes in the real world examples that some anomaly will be there, and here the model will not perform with the highest accuracy. So you have to take in these things also into consideration, the outliers part, and how our model is at not at the if it is not performing at its best at that part, it should perform at its mean part. Okay, so that model should not give its least performance. You have to check in which so if I elaborate more, you have to dive deep into, like, when I have worked as in the computer vision part, we have to check in with a single layer as well. We have to check in with the dropout layers. We have to check in with the activation functions as well. Some activation functions were performing good in the real world examples, but some were not. So we had to take a right decision. Okay, we'll stick with this activation function, we'll stick with these number of epochs. And those things are really important when we are training your network. So this take lot number of time, many hours, to come into on such a decision. But the data set, yeah, the data set is really a huge problem right now, because when you train your model with a data set, and if that situation does not appear in the real life, your model should be able to handle that situation with the right uh, right resources and right precision. That's what I can say. So our application was also was not performing really good at some part, like, but we had a precision with what angle or at what distance our application is performing well, at what intensity, like when we say frames per second, how it is taking into account frames per second as well. Okay, that is also important, how frames per second is also taken into consideration. Okay, so that such small details, how the video is, what the video quality is, 30 frames per second, how it is affecting, such small details is also really required for whenever you are designing any network or any model. So as I've told, it is a vast topic to talk on and to work on. When you start a project, you'll get to know what are the pitfalls in that project as well. So yeah, that were my pitfalls in my internship. Like, I had to check in with the video settings as well, I have to check in with the real life examples, I have to collect the data. I had to collect check with the data, not only with the videos, I had to check the demographic data as well. I have to check those maps for some data sets and all. So what I had explained in the second or third slide, just the data set where you have to connect those links. If my data set is CSV and I have to connect with there's some data set in the SAP, you have to connect those links. So that is the main point, and that we had faced. Second was okay. Another thing that we had faced, maybe we can say, certain number of classes were not trained, so we had to invest some time for training those classes as well, and it takes lot of time. Like whenever you are training on GPU or maybe on CUDA or maybe at your local machine also, it takes a lot of time, and you have to check that on your maybe stakeholders data set also. So maybe that those plus and minus points are always there. So yeah, these things we have to take into consideration, that our model is really precise enough to do that.
That's great. So, Darshana, thank you so much for your insights and your time today. We would like to conclude the session now. And since we have a lot of AI ML enthusiasts and students with us online, do you have anything to say to them as beginners and starters in this field?
Yeah, sure. As I think Piyusha also told me that there are a lot of new joins, like newbies to this world, artificial intelligence. So when I started artificial intelligence, so I would suggest it is never too late to start with artificial intelligence. Just start and just hop in, and there are a lot many opportunities. There are a lot many opportunities waiting for you. You have to just build. Even if you are from the mechanical background, you can just hop into AI. There are no backgrounds that that are not using AI, right? So as I have told in my slides, there are lot many opportunities present. So make use of the resources. Huge amount of resources are present on the Google, or on you can get on the website. Lot many competitions are there. So just if even if you don't know like what to do, just register yourself in those competitions. Just check in what are the statements and what are the data set that they are providing, right? Data set, and they are sometimes they are also providing the statements that are given from the companies itself. So sometimes those statements are given from the company, they provide their data sets. So that is really a good chance to look into the statements and get the data set as well. So then you can go in, like in machine learning, there's really a problem with data set. There are lots of values that are really missing, and you have to check in, and you have to sometimes SAP is also not giving us the value, so you have to put that values in place. So that capability of data processing is when you start working on. So just start working it, and yeah, you will get to know. Like today we had questions with the basic. Now when you start working on, you'll you'll be more way better than today's. Like, okay, we'll start with ANN. You'll be maybe in next a month you'll go to the ResNet and BGG models also. So the what I can say suggest is it's never too late. Just start then and just invest your time and just brainstorm. Even if you are from any background, can I implement this in my ENTC also, like electronics and telecommunication? As I'm from ENTC, can I implement certain things in ENTC as well? So start doing that and you'll be there. Yeah. And best wishes to you all. Hope to see you in the AI enthusiast groups.
Yes, Dee, definitely. Thank you so much, Darshana Dee, for this amazing session. It was very interesting. We could definitely relate how AI, ML, deep learning was used in the corporate world. And as we know, Git and GitHub are the most important tools as a software developer needs to carry in his toolkit. And this session definitely helps students to kickstart with GitHub. Thank you so much. It has helped us to bridge the gap between academia and industry. Thank you so much, Dee, for the interesting session. Also, thank you so much, everyone who joined this session today. And it was great having you all on board. And we will post the feedback form in the description. Please fill it up for us. Thank you so much.
Thank you so much. Thank you so much, AICVS, for letting me this opportunity. Also, Sandhya ma'am for taking up these opportunities with me. And yeah, any questions, we can connect on LinkedIn. I'll be glad to have a community where we as a group work on such topics, and we can come up with new solutions. So if any questions, please pin me on a LinkedIn, or you can just email me. I can help you out, or I can guide you out there. So yeah, just feel free to ask in your questions in there whenever you think that it is necessary. Okay, then see you as we get in forward with our careers.
Thank you.
Thank you all.